What is up, my students? A quick 3-7 review. So we're talking about absolute value equations. When you're solving an absolute value equation and it equals a positive number, by the way, it can only work when the number over here is greater than 0. Okay. What do you need to do is you need to solve that, whatever the stuff is, whatever the stuff inside the symbol is. Here's my little analogy here. So here's what the book says, here's what I say. Anytime you have stuff, if it's a single variable, more than one variable, an equation, whole equation here, you got to set that stuff equal to the number and the negative number, okay? So I'll show you what I'm talking about here. So you're going to solve two equations, if you have to. Sometimes you don't. So right here, we have the absolute value of x equaling 10. Well, how do you solve that? Well, there's not much to solve. X is going to equal 10. And x is going to equal a negative 10. Okay, these are the only two numbers that have an absolute value of 10. So it's a lone variable on the inside. It's literally just the positive and negative version of that. So if you think about it for a second, if you kind of hide the x, what two numbers could go in there? Well, 10 can go in there because the absolute value of 10 equals 10, and the absolute value of negative 10 equals 10. Okay, so again, when it's a lone variable, your answers are just going to be the positive and negative versions of that. The rule moving forward is if you have anything extra, if there's anything extra outside the absolute value symbols, you need to get rid of it like any other algebra equation. So I'm going to go minus 2. The absolute value of x equals 7. Hey, just like we got up top here, we have a lone variable inside the absolute value symbols, so your answers are just going to be 7 and negative 7. Great. Okay, next one. Now here's where you actually start having some stuff, okay? So here's the rule. The absolute value of stuff equals a number, positive number. Well, here we go. Set it equal to the positive and the negative versions of 12. So 2x has to equal 12, and 2x has to equal negative 12. So if you cover this up, what are the only two numbers that could go in there? Well, 12 and negative 12. That means 2x has to equal 12 and it has to equal negative 12, or I should say. So divide by 2, divide by 2, divide by 2, divide by 2. X is going to equal a 6 and a negative 6. There we go. Next one. Ooh, we got definitely lots of stuff here. Here we go. So stuff inside the absolute value symbol equals a positive number. By the way, folks, if you ever saw something like this, let's make an example here. Absolute value of something equals like negative 10. Can't happen. Okay. The absolute value of something cannot be negative. Absolute value has to do with distance, and you cannot really technically have a negative distance. Follow this rule. You got stuff inside the brackets, the absolute value symbols, set equal to the positive and the negative version of that number. Once you drop the brackets, it's okay to have negatives. All right, here we go. So what do we need to do? Well, we need to go 2x plus 3 equals 12, and we need to do 2x plus 3 equals negative 12. All right, here we go. So one step at a time. Minus 3, 2x equals 9. Divide by 2, divide by 2. Looks like x equals 4.5. That's one of my answers. The nice thing about these equations is you're going to be solving the exact same one. You're just going to get different numbers. Looks like we're going to have x equals a negative 7.5. There you go. So there's your two solutions, friends. 4.5 and negative 7.5. All right, so again, when you're solving equations, when you're solving these equations, if you have stuff inside the absolute value symbols and it's equal to a positive number, you set the stuff equal to the positive, you set the stuff equal to the negative, and you're going to solve. You're always going to find two answers. Again, if it's negative, you can't do any of that stuff. So nice way to skip things. Now, here's where things get goofy. When you're solving inequalities, either you're going to be solving less thans or you're going to be solving greater thans. You're going to be solving less thans, you're going to be solving greater thans. Here's the trick. When you are solving a less than, now it could be a less than plain or a less than or equal to. When you're solving a less than, you need to rewrite it like this. When the absolute value of something is less than a number, you're actually going to be making an interval. It's got to be less than the positive and greater than the negative of whatever this number is. Okay, so all you do is you kind of shift things around. Whatever stuff is inside the symbol, put it in the middle. Whatever this number is, it has to be positive. If this was a negative, you'd say, nope, can't do it. You put that number right here, then you put the negative number right here. So quick example. The absolute value of 2x has to be less than or equal to 10. Okay, here's what I'm going to do. 2x is the stuff. Stuff goes in the middle. I'm going to go less than or equal to 10, and then I'm going to go greater than or equal to negative 10. Okay, 2x has to be between positive 10 and negative 10. Okay, so you got to think about what numbers, sorry about the bell, what numbers have an absolute value less than or equal to 10? Well, that's from 10 to negative 10. Everything in between is going to have a absolute value less than or equal to 10. But instead of a regular x, we have a 2x. Oh, okay, sweet. Let's just solve it then. Divided by 2, divided by 2, divided by 2. I'm going to have a negative 5 over here, less than or equal to x, less than or equal to 5. Got myself an interval there, friends. 5, negative 5, solid dot, solid dot. Okay, those are all the numbers that are going to work for this. If you went past 5 to the right, wouldn't work. If you went less than negative 5, wouldn't work. So anytime you're doing a less than, you're kind of setting yourself up for an interval. It's like a range. It's a limit. Okay, you can only be these numbers. Anything past 5 or less than negative 5 will not work. You can take your time and check. Try some numbers in between, try some numbers outside. It's not going to work. Okay, so those ones aren't too bad. Less thans, again, a less than, if it's ever a less than, you take the stuff inside the symbol, put it in the middle, less than the big one, and then greater than the negative. And then you just solve like anything else. What else do I have over here? Anytime you're solving a less than, they're going to make an interval. They'll always make an interval, always. Okay. The one that's a little bit more complicated is when you're solving a greater than. So when you're solving a greater than, here's what you got to do. You take the stuff in the middle. It has to be less than the negative version of this one, or it's got to be bigger than the positive. Because what's going on here is it's almost a reverse interval. I call it a split interval, right? It's going to make a split. You got to be bigger than a number. That means you got to go find the greater than numbers or the less than numbers. So what this actually is going to happen is it's going to make one of these. You got to find all of those, and you got to find all of those. So you got to be less than the negative number, and you got to be greater than the positive number. Okay, again, so a greater than inequality with an absolute value is always going to make a split. Always, always, always. So here's the two things you need to write. Less than the negative, greater than the positive. Get that memorized. Less than the negative, greater than the positive. Less than the negative, greater than the positive. So here we go. We have x plus 2 is greater than 12. Here's my stuff. X plus 2 is my stuff. That had to be less than the negative, and then x plus 2 has to be greater than the positive. All right, let's solve. Minus 2, minus 2, minus 2, minus 2. I'm going to have x is less than a negative 14. X is greater than 10. If I were to graph that, I'm kind of running out of room here. If I were to graph that really quick, positive 10, negative 14, open circle that way, open circle that way. Okay, so here's all the numbers that could work. Again, when you're greater than, it's got to be greater than 12. All right, when you plug it into the x plus 2. So if you even tried 10, 10 would not work, okay? Because 10 plus 2 is 12. 12 is not greater than itself. If you tried negative 14, negative 14 plus 2 would be a negative 12. Absolute value is 12 again. 12 is not greater than itself. Everything past 10 will work. Like 11, 12, 13, you plug those in, it'll work. Everything under negative 14 will work. Negative 15, negative 16 will work. So when you're doing a greater than, again, when you're doing a greater than, it's always going to make a split. Here's what you set up. You don't actually solve this. This is what you set up and solve. When you're doing a less than, you don't solve this. This is what you set up and solve. So that's the hardest part, is setting them up. Once you set them up, you can solve them because we can do that. Setting them up is the new idea. Also, I'm going to give you a little bit of a cheating idea here. Anytime you're trying to find a range of error, they want you to do like a less than, because you want to be less than the error most of the time. They set you like a limit. Hey, you can only be off by like 10 pounds. You can only be off by 15 bucks. Stuff like that. The best way to find the range of error is to take the goal that you're going for and then add or subtract the allowed error, because you can only go so much over or so much under. So I think the example in the book is they were doing like box of crackers or something, and you can only have, the boxes of crackers were like 213 grams, and you could only be off either way by 5 grams. So if you take 213, add and subtract 5, you would have a max weight of 218 and a minimum weight of 208 grams. So there's your interval right there. I think the problem is talking about like a quality control person wants to know all of the allowed weights. Well, there's 208 and there's 218. So anything on that line, it was like a quality control question. Anything on that line would stay. Anything outside of that line would have to go back and they'd have to, or they just get rid of it. I'm not sure how quality control works, but anywho, that's it, folks. That is the 3.7 review. It was a dense one. Apologize, this video is so long, but hey, you do what you gotta do. Okay, peace out.